All right, what is soluble versus insoluble? For this exam, you're going to have to use the solubility rules that are listed in the back inside of your cover. If you don't have the back inside of your cover, some books might be missing that information. Please email me and I will get you a copy of it. When you're reading the solubility rules, it often says something is soluble or insoluble. But what does that mean? Something that is soluble, think about like pouring salt in water. It dissolves, right? You don't really see it. When it's soluble, it means it exists as ions in a water solution. And when we're trying to predict products, we would denote that as being AQ for aqueous. So if I had sodium phosphate and it was soluble for one of the products that I predicted, what that would say when I'm saying it's aqueous is in a liquid solution, it would be floating around separate as ions. That's really what a soluble compound means. It's not connected to each other. It's literally ions doing, backstroke or front stroke, whatever. I don't swim, but they're swimming, okay? So when you do the solubility rules, you denote that as an AQ as you predict them. On the solubility rules, when something is insoluble, it means it makes a solid. And you're going to denote that by writing an S by that compound as you predict. The S represents a solid. It does not represent it soluble. Some students use the S because it exactly matches the beginning of soluble. But something that's soluble over here is shown that you need to indicate it as AQ, meaning it's aqueous. Something that's insoluble on the solubility rules is an S. So using those rules that right now we're going to go through these compounds to determine if they would be AQ or S, if they were actually a compound that we had predicted from one of the double replacement reactions. You go to K3PO4, potassium phosphate. Rule number 2 is your most important rule. It's the only one that has a cation rule. All the others look at the anion part of the compound. It's important that you mark rule number 2 as your first go-to. If I do that, then it has a potassium ion, or potassium in it, which automatically makes this an aqueous compound, meaning it's going to exist as ions. If I go down to AgCl, I go to rule number 2 still to see if it's potassium, sodium, or ammonium. It's not, so I have to look at that anion part of the compound because the rest of the rules follow that. It says all chlorides are soluble. And then it says, except if it's attached to these specific ions. And silver happens to be an exception. So go on and read that exception part of the rules. By just merely putting a sodium, potassium, or sodium, potassium, or ammonium onto the chloride ion, it goes into rule number 2, making compounds soluble. All right, now we're going to look at calcium sulfate over here. Again, it's not rule number 2 that we're looking at, so we're going to look at sulfates. Sulfates are soluble, except if it has calcium on it. It has some other exceptions listed on there, but calcium is one of those exceptions. So it makes it insoluble. It means it's a solid. Take a look at lead chloride here on the bottom. I'm going to refer to my rules. When I take a look at it, it says chlorides are soluble, except if it was PbCl2. So the fact that lead has a different oxidation state over here makes it insoluble, and this, because it has a +4 charge, makes it soluble. So read the rules, go to rule number 2 first, and then go ahead and make sure you read on if there's any exceptions to what those are saying. And this exam is using that to predict products as well as ask about solubilities of compounds.